10.2 is all about simplifying radicals, and this is just day 1 of it. We get 3 days, yay! So what is a radical? A radical is just an expression with a root. So square roots, cubed root, any of these. So for an example, here's a radical. It's the cubed root of 27. The 3, which I'm calling cubed root, is the index number. The symbol is the radical. So this symbol is the radical. And the number underneath it, or the expression underneath it, is called the radicand. So there's only 2 rules when it comes to radicals. The first rule is that no fractions are allowed underneath a radical. And no radicals are allowed in denominators of a fraction. So how do we simplify radicals? If you would plug the square root of 8 into your calculator, you would get this number 2.828427125, and it will go on forever. We want the exact answer. We don't want a rounded answer. So how do we find the exact answer? We break up the square root, the radicand, into its parts. So let's look at square root of 8. I'm going to do it 2 different ways. I will rewrite square root of 8 as the square root of 4 times the square root of 2. And oftentimes I just do it under one radical, like this, square root of 4 times 2. I happen to know the square root of 4 is the number 2. So I could go right now, I'm going to take a 2 out because I know the square root of 4 is 2. And then I would have 2 square root 2. If you didn't know that, you would have done this step. So you'd say, I can still break up 4. So I'm going to break it up into 2 times 2. And then my 2 still comes down. So I have 2 times 2 times 2. And the rule is, here is 2 squared, right? Or 2 times itself. So the square root of a squared number is what's underneath. Or here's this rule. If you have 2 underneath a square root symbol, 1 comes out. It comes out of the radical. So I have 2, and then what's left in? The square root of 2. Sometimes people do it with factor trees. I'm not a big fan of factor trees. But if I want to get prime factorization of 8, you might remember you would do 4 times 2, and then this 4 would break up into 2 times 2. I think they get long and it's easy to lose a number, but then you look for 2 things together. So I have a pair of 2's. So if I have 2 2's, I know 1 comes out of the radical, and then this 2 that's all by itself would be left in. So either way, you're going to get 2 square root 2. I personally don't like trees because I get lost, but if you can follow them and you can do a tree, that's fine. All right, so square root of 32. I break it up into numbers that I know. What times what is 32? First of all, actually, I tried on my calculator to see if it's a perfect square if you don't know, because otherwise you're going to go through some work and you wouldn't need to. So hit square root 32, see if it's a whole number. If it's not, or you can see what you get. And if you get a decimal, then you know you're going to solve it a different way. So I know 32 is 8 times 4. Square root of 8 times the square root of 4. I'm going to break 8 up into the square root of 4 times the square root of 2. I still have that other square root of 4 coming along. And I'm hoping that you recognize square root of 4 is just the number 2. The square root of 4 is the number 2. So not the square root of 2, it's just 2. And the square root of 2 I can't break up. So square root of 2 just stays under the radical. Now I multiply the numbers on the outside and I would get 4 square root 2. And again, I'm going to take this step. If you weren't sure that 4 is a perfect square, we could have went back to that step and broken it up into square root of 2 times the square root of 2, because I know the square root of 4 is, I know 4 is 2 times 2. So that's my first 4. I have that middle square root of 2 that was there, and then I have that second 4 that I need to break up. Well, I have 2 together, 1 comes out. I have 2 together, 1 comes out, and I'm left with 1 in. So here again, I would have 4 square root 2. All right, 160. So put me on pause. Think about what you would break 160 up into. There's a number of options, but you can put me on pause and then see what you come up with. Okay, I'm going to do, I know it's 16 times 10. And I know 16 is 4 times 4. 10 is 5 times 2. Okay, again, we have 2 4s. So if I have 2 under the radical, 1 can come out. 5 I can't break up, 2 I can't break up. So since I can't break them up anymore, I'm just going to put them back together under 1 radical. So I have 4 square root 10. I put the 5 and the 2 back together. All right. Again, put me on hold and you try this one. Okay, and then if you did this, you should have gotten 6 square root 2, and you'll see that it says you must show work for credit. So you have to have work on your paper to get credit for these notes. All right, remember in chapter 9 when we had the square root of x squared? That was just x. Because again, the square root of x squared is x times x. We have 2 together under the radical, so 1 comes out. All right, so simplifying radicals with variables, in this case we have more than just x squared, but we have the square root of x times x times x times x times x. That's what x to the 5th is, remember? And again, the rule is if we have 2 under the radical, 1 can come out. Well, how many groups of 2 do we have in that 5? There's a group of 2. There's a group of 2. So 1 comes out for that. 1 comes out for that. And I still have 1 in. Now, x times x I can put back together. It's x squared, square root x. All right, this time we have numbers and variables mixed together. So 54, I'm just going to think about my numbers, is 9 times 6. And then we have end of the 7th. So let's see, we have, how many groups of 2 do we have here? We have 3 groups of 2, so I can take 3 n's to the outside. I know that 9 is actually 3 times 3, so there's 2 3's. I can take 1 out. I'm going to put that in front of the n's. I have left in there the 6 and n. I can't do, 6 is 3 times 2, but again, there's no perfect squares there. So I'm just going to leave 6n under the radical. And now I'm going to put my n's back together as 3n cubed, or to the 3rd power, and square root of 6n. All right, another example. So this is going to just stay on the outside as negative m. And then we're going to have a square root. Let's break our 80 up. I know it's what, 10 times 8? And m to the 9th. Ran out of room, sorry. All right, so 10 can be broken, I'm going to leave my m out here. 10 can be broken up into 5 times 2. And 8 is 4 times 2. And then I still have my 9 m's. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so let's see, I have a pair of 2's. 2 in, 1 can come out. I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that is 4. 4 pairs of m's, so I can take out 4 m's. And I have this 4. I know that 4 is another 2 times 2, so I can take out another 2. And then we still have this negative m from here. So let's see. So I have everything circled out. This 4 I simplified. So what do I have left in? A 5, which can't do anything with, and an m. So now let's clean up what we have on the outside. This is like a negative 1m. So I'm going to multiply my numbers times my numbers. So I have negative 1 times 2, which is negative 4. And then I have m, 2, 3, 4, 5m, so m to the 5th, square root of 5m. And this is square root. I haven't really talked about this yet, but that's a 2 there. We just don't write it just like we don't normally write a 1 in front of a variable. If there's nothing there, we know that it's square root. All right, again, put me on pause. You try this. You have to show work for credit. I'll put the answer on the bottom when you come back. All right, so hopefully you showed your work and you ended up with negative y squared or negative 1y squared, square root 6y. If you need help, ask in class and I can show you how to do it. All right, solve this quadratic, find the exact solution. So solving quadratics, hopefully you remember back earlier when we were talking about the solutions to a quadratic are called the roots, the zeros, the x-intercepts. And how do we solve for it? We factor or do the quadratic formula and set the results equal to 0, right? So if we have to find exact solutions, my guess is they're not going to be beautiful numbers, so it's not going to be factorable. So what is the first step for doing the quadratic equation? We get everything to one side, remember? And we have n squared minus 2n minus 4 equals 0. Label my a's, b's, and c's. So a is 1, b is negative 2, and c is negative 4. And then quadratic formula. Sorry. I was trying to decide if I should sing it. So Nicole, please, sorry for my voice. The opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So the opposite of b, or negative b, so negative, negative 2 makes that a 2, plus and minus the square root, negative 2 in parentheses squared minus 4 times a times c all over 2a. So I would simplify what's under the radicand, so we have negative 2 squared. Remember that's negative 2 times negative 2, which is just 4, minus 4 times negative 4. So what is under the radical is 20. So I have 2 plus minus the square root of 20 all over 2. Now last chapter, we just let you plug that into your calculator and get an estimate round to the nearest whatever we said, right? But this chapter, that's not how this is going to work. We are actually going to simplify that. So let's look. We have 2 plus or minus the square root of 20. So we're just worried about that square root of 20. I'm going to pull that over here. So let's simplify that square root of 20. And we know that that's the square root of 5 times the square root of 4. Square root of 4 is the number 2. So we have 2 square root 5. Or I could have done, which is square root of 5 times 4. And then rewritten it as square root of 5 times 2 times 2. I have 2 together, so 1 comes out. And you get 2 square root 5. But either way, it's 2 square root 5. So now I have 2 plus minus 2 square root 5 over 2. And so oftentimes I'll get kids that will say, hey, can I simplify? So up here and make this 1 plus minus the square root of 10. And the answer is absolutely not, because the square root of 20 isn't actually an even number. It's not divisible by 2. If you plug the square root of 20 into your calculator, you're going to get a number, a decimal, so it's not divisible by 2. But these 2's all are just numbers, and we can divide or simplify those. So this 2, if I factor out a 2, or excuse me, divide by 2, those are both gone. So I have 1, because 2 divided by 2 is 1, plus or minus the square root of 5. So that is my answer, 1 plus or minus the square root of 5. All right, that's it. Enjoy the rest of your day.